Okay, now continuing on with problem number 5. The costs charged by two taxi services are represented by the two parallel lines on the following graph. Speedy taxi service charges 180 plus 10 centimeters per kilometer. And that would be this line. Starts at 180 and then it goes up 10 centimeters per kilometer. You can see that each one of these blocks is 2 kilometers, so it has to jump 20 cents per kilometer. So you can see if you drew the slope of this, you would see that you would have the rise would be 20 cents, and then the run would be 2 kilometers. Okay, so it would end up being, 10 cents a kilometer. Okay. Write an equation for the cost C in dollars of using the economic taxi service for any number of kilometers K. So for the economic taxi service, it starts at 140 and it goes up also 10 cents per kilometer. As you can see, it's the same gradient as the speedy taxi service. So we would write that just like we did in our exploration. We would have the cost equals the starting price or the initial fee, which is 140, plus the number of kilometers times the price per kilometer, which is 10 cents. We'll put the 0.10 because that's 0.1 is $0.1. Okay. Now, you remember when we write the gradient intercept form, we write mx plus c. So that would be reversing these two. So the 140 we would actually put last, and the 0.10 you would put instead of the m, and then you would put x plus. So that's how you would write it in mx plus c form. So that's the equation. You could either write it this way, you could write it this way. Okay, now Bruce uses the economic taxi service. How much will he pay for traveling 7 kilometers? Well, we could kind of see that from the graph, right? So like 7 kilometers would be here. And you can see that that would be equivalent to $2.10, right? 2.10. Now, you could also do that with the equation. If you put 7 in for x, then that would give you 70 cents plus 140. And what do you know? That also gives you 2.10. So you could do it graphically, or you could do it with the equation. Now the last part is how far can you travel for 240? Now 240 is the cost, right? So you could do this with algebra. You could say 240 equals 140 plus k times 0.10, okay? Or you could do it graphically. If you look at 240 here, we're talking about the economic taxi service, so that would cross the economic taxi service here. So how many kilometers is that? Well, this was 8, so we're jumping by 2, so that would be 10, right? So the answer would be 10 kilometers. And you could do it by algebra too, using this. So 2.40 equals 1.40 equals k times 10, 0.10. So we could subtract 1.40 from both sides. I'm doing algebra here. That would be 0. This would be 1.00 plus 0.10k. So now we just have we would have 1 equals, like $1 equals 0.1k, and we divide both sides by 0.1, and that would give us 1 divided by 0.1. You could do that with your calculator if you want. So it'll be 1 divided by 0.1. It's 10. So the left side is 10. The right side, 0.1 divided by 0.1 is 1. So k equals 10. What do you know? It's the same answer as we got solving graphically. Okay. Okay, now here's the last problem. 6 vertices of quadrilateral ABCD are in the diagram, shown in the diagram, and the points are given here. Okay, so they not only give you the points, but they also graph the points. So we won't go into that, but so the gradient of line AB is -5/16. So they're talking about this line here. So they've already calculated the gradient for that too. And remember, the way they would do that is they would take this coordinate and this coordinate, and they would just do rise over run for those two coordinates. Okay? Or they would just look on the graph and they would count these. They would count these units on the rise over run. They could do it that way too. You can see it's sloping down, so that would be a negative gradient. So we shouldn't be surprised that it's negative. Okay. Now let's calculate the gradient of line DC. Now there's a couple ways to do that. Remember, we could take this triangle here. We could calculate using that triangle. Let's do it that way first. Okay. So we can see that the rise. Now we're going, this way. So the rise is -2, right? Because it's going down. The run is positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So the run is -2, and it's divided by, or the rise is -2, and the run is 11. So this would be the gradient. We could also do that using the coordinates, 7, -1, and -4, 1, and so we take the difference of 1 and -1 divided by the difference between 7 and -4, right? And remember, there's also the calculator method, and I'll show you that here. We could put those 2 points into the calculator using stat edit. So we would put the x's in the L1 column. So I'd put 7 and -4. And in the other column, the y column, I would put -1 and 1. And then I would use stat calc. Oops, sorry about that. That was wrong. I do stat calc, and then when I go to calc, I'm going to go to lin reg. So I could do that by pressing 4, or I could use the arrow keys, but I'm going to press 4 because it's faster. L1 is where we have our x's, so we'll leave that. L2 is where we have our y's, so we'll leave that. Frequency lift should be blank because we don't have multiple points. We only have one of each. Then I'm going to go into calculate and hit enter. It's going to give me the formula right here. It's going to give it to me in decimal, but you could write the gradient. See, the A is the gradient, right? So -0.181818 happens to be a -2/11. Okay, and then now we already have the y-intercept of the line too, which, looking at the graph, you can't really tell exactly where that is. You would have to use the calculator or algebra to figure that out. Okay. State whether or not DC is parallel to AB and give a reason for your answer. Well, the gradient for AB is -5 divided by 16, and the gradient for DC is -2/11. So those aren't the same number, and to be parallel, the gradients have to be the same. So yeah, gradients not the same. Okay. Now part C, find the equation of the line through BD and express your answer